we import TensorFlow as TF, and then we print the TensorFlow version. We are using TensorFlow 1.0.1. Now we're going to create two TensorFlow variables that will hold random numbers. We use TensorFlow variables so that they maintain the same state across multiple calls of the session run. We're creating this TensorFlow variable using the TensorFlow random_uniform functionality. We're going to generate a tensor that is 2 by 3 by 4, has a minimum value of 0, a max value of 10, and the data type is TensorFlow int32. Int32 is a 32-bit signed integer. So that is random_tensor_var_1. We define random_tensor_var_2 the same way. We use the TensorFlow random_uniform. We have a tensor that's 2 by 3 by 4, min value of 0, max value of 10. The data type is also int32. Next, we use TensorFlow global_variables_initializer so that when we run the session, we can initialize all the variables. Then we define our session variable and initialize all our variables. So here we're going to have two variables, remember, random_tensor_var_1 and random_tensor_var_2. First, let's print our random_tensor_var_1 to see what it looks like. We see that it is integers, and it is 2 by 3 by 4. Next, we print our second tensor, and we see that it is also 2 by 3 by 4. It's all integers, and it is a completely different tensor from the first one. To concatenate tensors, we're going to use tf.concat. What we do is we pass a list of tensors, and then we specify the dimension we want to concatenate across. We are going to concatenate across the 0th dimension. Remember, Python is a 0-based index, and we're going to assign this concatenation to Python variable concat_tensor_dim_0. Now we're going to print the result. We evaluate the variable inside of the session, and we print the result. We see that it has the 4 matrices. So 6, 5, 4, 1, 2, 3, 5, 8, 3, 4, 9, 0. They are all there. And we can run TensorFlow.shape on our concat_tensor_dim_0 variable, run it in the session, and print the result. And we see that it is 4 by 3 by 4. This is expected. We're concatenating the two tensors across the 0th dimension, so that would be the first dimension. Since each TensorFlow tensor was 2 by 3 by 4, we see that it is 4 by 3 by 4. So we have these 3 by 4 matrices, and there are 4 of them on top of each other. We're going to do another concatenation between random_tensor_var_1 and random_tensor_var_2. This time we're concatenating across dimension 1. We use the TensorFlow.concat functionality, and we're going to assign it to the Python variable concat_tensor_dim_1. We evaluate the variable inside of our session and print the result to see that we have one matrix here, one matrix here, and it is now 1, 2, 3, 4, 5, 6 rows by 4 columns. So we have 2 matrices, 6 rows, 4 columns. So when we use the TensorFlow.shape to get the dimensions, we can see that it is 2 by 6 by 4, which is what we expect because each tensor originally was 2 by 3 by 4. So when we concatenated it across dimension 1, we would expect the shape to be 2 by 6 by 4. The last concatenation we do is across the second dimension. Remember, this tensor is 2 by 3 by 4, so it has 3 dimensions. Python is a 0-based index, so this 2 will be the last one. We assign it to the Python variable concat_tensor_dim_2. We print the result, and we see that we have 2 matrices with 1, 2, 3 rows, and 1, 2, 3, 4, 5, 6, 7, 8 columns. When we print out the shape using the TensorFlow.shape functionality, we can see that it is indeed 2 by 3 by 8, which is expected. Each original tensor was 2 by 3 by 4, so when we concatenate it across the second dimension, we would expect this to be 2 by 3 by 4 plus 4, which is exactly what we got. The last thing we do is we close the TensorFlow session to release the TensorFlow resources we used in this session as we no longer require them.